This is question 25 from exercise 5.5 and 5.6. Over here, we're given a question about salary, and we are told that at the start of 2014, it is 60,000, and every year it is increased by 4% of the previous year's salary, and also by 5,000. Now, this order here is very, very important. According to an agreement he has with his employer. Okay, fine. Part A, use a recurrence relation to model this situation. So how do we model this? Well, let's start with part A. So we can start with, let's just say the salary is Sn plus 1. Now remember, this is a recurrence equation, so Sn plus 1 must be on one side and Sn on the other side. But how do we figure out how this right-hand side looks like? Well, first of all, we know that it's increased by 4%, and then there is an additional $5,000. So these two things are very, very important pieces of information. So this increase of 4% and also by 5,000. So we're going to work both of these things into the recurrence equation. So let's start with the increase, because we're told that's what happens first, increase of 4%. So now if it's an increase, we would then multiply the previous year with this 1.04 of Sn. That's the decimal, right? 100% plus an additional 4%. And then we would add 5,000 to it as well. So that fulfills these two parts, the 4% and the 5,000. But we have one more piece of information for a recurrence equation. You would also need the first term, and the first term here is, in the first year, he gets $60,000. Okay, so that's part A. B. What is Hugh's annual salary for the year 2017? Now we start with S1. S1 here is for the year 2014. So logically speaking, we can then count that 2015 will be S2, S3 is 2016, and finally S4, that would be 2017. So we're going to use this Sn plus 1. Sorry, we're going to use the entire recurrence relationship to figure out what is S4. Now, since we have the recurrence relationship, we can just use cas and generate a sequence. So your sequence is going to basically look something like this. We would type in, okay, you would see un, and un you would type in 1.04, where this is actually u, and minus 1, and plus 5,000, and you would also key in your initial term, and that would be 60,000. That would be your S1. And from here, you'll be able to generate a sequence, and a sequence would look something like this. So this is part B, continued. Okay, you see a table, and these values would be 1, 2, 3, 4, and so on and so forth. The first value you would see is 60,000. This would be 67,400. Whoops, sorry, extra 0. And after this, you would see 75096 83099.84. Okay, so what do all these numbers mean? This here, this is S1, that's S2, that's S3, and this here is S4. Therefore, S4 is going to be 83099.84. What this basically means is that in 2017, his salary is 83099.84. That's basically what it means. Okay, so let's move on. Next point. In which year will Hugh's salary first exceed $100,000? Okay, so if we continue this table, we actually can scroll down further and look at the next few values. You will see that the fifth value here is 91423.2. 1.83. The next value here, S6, is going to be $100,080.79. So once again, if we use our sequence from before, this is actually S5 and this is S6, and we can see that it is S6 where we will hit and also exceed $100,000. So we can answer this question, and we can say that this is part C. You can write down using CAS. Okay, S5 is 91423. This is in dollars, and S6 is $100,080.79. And we can write down that Hugh's salary will first exceed $100,000 in the 6th year. And that's our answer, and that's how we do question 25.